for completing performance task 4, which is the Sierpinski triangle performance task. So some real basic tips when you're going through the task in haiku is, first of all, look for anything that's red font. These items are going to refer back to tables that are values that you are creating in your tables. And your tables are posted online, but you're also going to have a piece of paper for that you can write your work in for those tables. You need to leave all your answers in radical or fraction form. Don't use decimals because you won't see the patterns that you need to see. Remember that perimeter means you add up the length of all sides of something. In this task, you're going to use the formulas we've used in this unit. So look for hints to use the formulas. It actually says hint, use a formula. So you're going to be looking at your a sub n formulas and your sum formulas throughout the task. Make sure you're using the correct formula before you use it. So really double check to make sure if your sequence is arithmetic or geometric, or if it's a sum formula, and if it's a finite sum or an infinite sum. And then remember to check your values in your table. So make sure to test them, so make sure that whatever formula you create works for all of your values. So when you create a formula, go back and check the numbers that you have and make sure it works for all of them. And then also you need to be open to looking for patterns. This task is all about creating formulas from patterns. So speaking of patterns, we're going to talk about a couple of patterns, and you're probably going to see these patterns in the task. So a 2 pattern. So when you see a sequence of numbers such as 2, 4, 8, 16, 32, we would know that that's geometric. It's with the common ratio of 2, right? So because we keep multiplying those numbers by 2. So if I think about that pattern in a little bit different way, I think about it in terms of the term number. So if you see here, my term number is 0 and 2 to the 0 is 1. My term number is 1. When I put 2 to the first, I get 2. My term number is 2. 2 to the second, I get 4. 2 to the third, I get 8. And 2 to the fourth, I get 16. 2 to the fifth, I get 32. So whenever you see a pattern that looks like this, if we were going to talk about it in general or write a formula for it, we would write 2 to the n. So we could do this something similar with 3s. So for the 3s, we would be looking at 3. I'm missing something there. There should be a 9. It should be 3, 9, 27. So my numbers are a little bit off here. Let's just fix that. 9, 27, 81, and 243. If we caught it. And so on. So again, we can use this for the 3s as well. So when we see a sequence of numbers like 3, 9, 27, 81, 243, again, we were multiplying by 3s. It's still geometric. All right. And to create it, we do something similar. We do 3, the base number or the ratio to an exponent, kind of like 3 to an n or an n minus 1. And again, the formula we would write in general is 3 to the n. We could also do this for 4s. So if I get 4, 16, 64, 256, 1024. So again, to create this sequence, we multiply by 4s. And it creates a very similar pattern that we saw with the same thing with the 2s and the 3s. And for this formula, we would write 4 to the n. The other thing that comes up in the task is side length of equilateral triangles. Well, an equilateral triangle by definition means that all the sides are the same length. And they're going to tell you in the task that the side length is equal to 1. But then they're going to say they're going to add some more triangles in to create Sierpinski's triangle. And then they're going to change the side length. So, oops, that went a little too fast. So if I layer these triangles on top and I create another set of triangles at the midpoint would mean that I would now have triangle lengths of 1/2, because I'd have half there and half there. Then if I did it one more time, I make a triangle pair at a midpoint here and a midpoint here. Now I have 1, 2, 3, 4, meaning all the purple triangles, their side lengths all the way around are 1/4.